Today on What's Your Problem? We'll learn to find the area of polygons by decomposing shapes. We'll also learn how to find the area of polygons displayed on a coordinate plane, and we'll see how this knowledge helps people create video games, build houses, and even skateboard ramps. Hey, I'm Adesina, and welcome to What's Your Problem? The show where we solve all of your problems.
The weekend is almost here, but can anyone explain why Friday is so close to Monday, but Monday is so far from Friday? I mean, come on, it's a tragedy.
No, not those kinds of problems. Math problems. Today's topic is finding the area of a shape through decomposition. For example, here we have a kite. A kite works by wind pushing against its surface. So the question is, how can we calculate the area of this kite?
I remember that area is the space inside of a 2D shape.
And we can calculate the area of a rectangle by multiplying its length by its width. Would that work for this kite?
Well, it would not, because this kite is not a rectangle. One way to find the area of this shape is to break it apart into simpler shapes.
Oh, I think I get it. We can find the area of this kite by breaking it apart into two triangles in one rectangle.
Yes, and that's the concept we'll explore today. I'll show you how this knowledge can be used to build a house, a skateboard ramp, and even create a video game. Let's explore. Before we dive into today's topic, let's briefly review what we already know about area.
Area is the amount of space inside a 2D shape. It is measured in square units.
For example, if this rectangle is 6 centimeters long and 5 centimeters wide, we could count all the square centimeters inside of it, which is 30. Or we can multiply the length times the width. 6 centimeters times 5 centimeters is 30 square centimeters.
Good. Now that we've refreshed our memory, let's look at finding the area of triangles. First, let's see how finding the area of a triangle can help us skateboard.
Rad ramp, Adesina!
It's gnarly, right? I'm looking to build another ramp just like this one. But to know how much wood I need to buy, I need to find the area of this triangle.
I know that this is a special type of triangle called a right triangle because it has one angle that is 90 degrees.
Correct. Let me show you how to find the area of a right triangle. This rectangle is 10 centimeters by 5 centimeters. So what's its area?
Well, 10 centimeters times 5 centimeters equals 50 square centimeters. So its area is 50 square centimeters.
Right. Now, let's cut it in half diagonally.
Awesome! Now we have two right triangles.
Good. Now, can you tell me what the area of one of those triangles is?
If the area of the rectangle is 50 square centimeters, then one of these triangles must have an area that is half of that.
Which would be 25 square centimeters.
Well done.
So the area of a triangle is just half the area of a rectangle?
Correct. We can show that with the following formula. The area of a triangle equals 1/2 times base times height. The base is how long the triangle is, and the height is how tall it is. Try to use the formula to find the area of this piece of wood, which is 100 centimeters long and 30 centimeters wide.
Since it's a right triangle, we can just plug the values into the formula. Area equals 1/2 times 100 times 30.
We can multiply these values in any order, thanks to the properties of multiplication. 100 times 30 is 3,000. Then 1/2 times 3,000 is 1,500. So the area of this right triangle is 1,500 square centimeters.
Rad! Next, let's see how we can find the area of more complex shapes. Let's see how finding the area of polygons can help people build homes.
During the summer, I volunteer to help build homes for people in need, and every home starts with a blueprint.
This blueprint shows the floor plan for a home.
If we find the area for each room, we will know how much wood, tile, and other materials we need to buy.
The only problem is this room is shaped like a parallelogram and this one is a trapezoid. How are we supposed to figure out the area?
Remember when Adesina showed us the kite? It had a similar shape, and we saw that it can be broken down into triangles and rectangles.
Oh yeah, let's try to break these shapes into rectangles and triangles. I'll try it with the trapezoid first. If we split it here, we get one rectangle and one right triangle.
Neat! We already know how to solve those, so we can find the area of the triangle and rectangle separately. Then add them up.
Nice. Try to find the area of the rectangle first.
I can see that it is 6 meters long and 3 meters wide. 6 times 3 equals 18. So the area of the rectangle is 18 square meters.
Now I'll find the area of the triangle. I see its base is 4 meters and its height is 3 meters. 4 times 3 is 12, then half of that is 6. So the area of this triangle is 6 square meters.
Good job. Now let's add the areas of the rectangle and the triangle to find the area of the entire trapezoid.
6 plus 18 equals 24 square meters.
Exactly. Now let's find the area of the parallelogram room.
It looks like we can decompose the parallelogram into 1 rectangle and 2 triangles.
I see. The rectangle is 5 meters long and 3 meters wide. 5 times 3 equals 15. So its area is 15 square meters.
This triangle has a base of 2 meters and a height of 3 meters. 3 times 2 is 6 square meters, and half of that is 3 square meters.
And look, this triangle has the same measurements, 3 meters by 2 meters. So it would also have the same area, 3 square meters.
Now let's add up the area of these shapes. 3 square meters plus 15 square meters plus 3 square meters is 21 square meters.
Excellent. So remember how in math there's often more than one way to solve a problem? Well, check this out. If we move one of these triangles to the other side, we get a rectangle.
Which we can find the area of in one simple step, length times width.
That's right. Try it.
This new shape is 7 meters long and 3 meters wide. 7 times 3 equals 21 square meters. It's the same answer.
Great. Next, let's see how a coordinate plane can help us find the area of more polygons. Are you ready to see how drawing polygons on a coordinate plane can help people design video games?
Yeah.
This should be awesome.
It will. Now remember, a coordinate plane is made of 2 number lines. The number line that goes to the right is called the x-axis, and the number line that goes up is called the y-axis. The coordinate plane allows us to specify the location of a point.
So, to design the video game, we can use the coordinate plane to map out where everything will be located in the game.
Good idea. I remember we can mark points on this coordinate plane using ordered pairs. For example, this is the point 8, 5, which is 8 units to the right along the x-axis and then 5 units up in the direction of the y-axis.
Exactly. Let's start by drawing a hexagon, which will represent where a building will be in our game. The hexagon will have its corners located at points 5, 2, 7, 2, 9, 4, 7, 6, 5, 6, and 3, 4.
Let's put the first corner at 5, 2, which means we start here at the origin and move 5 units to the right and 2 units up.
To plot the next point, 7, 2, we start at the origin and move 7 units to the right and 2 units up. From there, we can add the point 9, 4, which is 9 to the right and 4 up. Then 7, 6, which is 7 to the right and 6 up. Then 5, 6, and finally 3, 4.
And now we can connect these points to form a hexagon.
Correct. That's a good-looking hexagon. Can you find its area?
I can see that this hexagon is made of a 4 by 2 rectangle in the center. And we can decompose the rest of it into 4 right triangles.
Neat. So let's find the area of each part and then add it up. The area of the rectangle is 4 times 2 equals 8 square units. This triangle has a base of 2 units and a height of 2 units. So we can find its area by multiplying 2 times 2, which is 4, and then half of that is 2. So its area is 2 square units.
And look, this triangle has the same dimensions. And so does this one, and so does this one. So the total area for all 4 triangles is 2 plus 2 plus 2 plus 2 equals 8 square units.
To find the area of the whole hexagon, we can add all those parts together. 8 plus 8 is 16 square units.
You both rock! Now that we found the area of the hexagon-shaped building, we can do the creative part of making our video game.
Yeah, like animate the scenery.
And the characters.
That looks like it's gonna be a fun game.
So fun! Next, let's see how this knowledge can help us with different careers.
Wildlife ecologists are scientists that study animals and how they interact in the wild. They calculate area when setting up conservation zones. Knowing the area of those zones makes it easier to maintain a healthy ecosystem. For example, elephants need a lot of space to roam, so it's important to calculate how much area they have.
Aerospace engineers use science and math to make things fly. They calculate the area of polygons in their designs all the time. Like when making an airplane. If the area of the wings are too large, the plane could be too heavy. Too small, and it may not be able to lift into the air.
Mural artists use area when planning their work. To make their job easier, they break the area of the wall into small squares, and as they fill them in, the big picture comes to life. These are just 3 of the many careers that use area.
Now, let's review.
Today, we learned to find the area of polygons by decomposing shapes.
We also learned how to find the area of polygons displayed on a coordinate grid.
And we saw how this knowledge helps people create video games, build houses, and even skateboard ramps.
And now, we've solved all of your problems. Well, almost. I'm Adesina.
I'm Emily.
I'm Amari.
And until next time, remember,
Always question, always wonder.